I'm back here with Dr. Levon. We're really going to get into it now. Dr. Levon, does light really get distorted the way Einstein explained it? Or tell me, is there more to it that scientists really don't even know?
Okay, let's get into this. Why exactly? Why the Einstein he thought the light get distorted to begin with? Because when you look behind each planet, they're in a certain spot has a dark area. But after that, slowly the light it comes out and it lives like a long exactly like if you imagine this is the planet and that has like a long angle after that slowly and the what it causes the light actually to be take angle shape and go all the way farther away and then join back again. How that possible? Even though I said the photons they don't have that much of an energy left within them, but what is happening? We gotta see how far of the angle the light hits when the angle you see, when the angle when you look at it, now you see depend what angle the photon is hitting. When it hits the way tip of the planet, it actually will bounce off and hit other photons and it can change the direction, and that's how it turns angle. It gives angular shape, and what exactly happened that? Why it happened that again I said the photons they don't have much of a energy left within them. Even the sun is able to capture those photons, but the earth energy is not strong enough to detect those photons. Now any planet which one within our solar system, when energy travels throughout the solar system, it leave behind long trail of dark area, but and then within a certain area again it leave like a triangle. Within that triangle again depend I said how far the energy how big it is. It goes according by the size of the planet. If the planet is larger, it will live larger dark area. If it's small, it will live in a small dark area. This is the reason when you see we have on the earth time to time when the earth blocks the sun, it blocks actually the sun from our view. The reason why, because the distance between the moon and earth is very close, only 250,000 mile distance. And this is the reason why you see the moon, it's able to block the sun's energy from the earth. Now if the moon had a little more distance than what it currently is, we wouldn't see any moon shadow. But the reason we see in the moon shadow, because the moon, the distance between the earth and the moon. Now let's check it out. Again I said let's check it out. Why the fact? Let's take the fact and check it out. When you're walking on the street, sunny day, it depends how much of an angle sun has, and accordingly you will see your shadow just walking with you and just following you everywhere where you go. The reason why, because the sun the energy doesn't disturb the way Mr. Einstein he explained. Whatever it comes, it penetrates into your body or penetrates to the ground, and it stays right there. The only reason, again, I explained, that when it depends the angle, what angle hits the photons. If within an angle when it cannot penetrate and stay within the ground, it will bounce off back and go into the space again. And that's when they're hitting the other photons, which one just following with them. And just by shooting them, it just they change the angle. Like take one small example. If we take the ball and we hit it to the ground, 45 degree, it will bounce all back 45 degree. That's the way exactly everything function within the universe. It's no exception to the rule. You hit the ball to the ground 75 degree, it will bounce all back 75 degree, and that's the way it goes. Now the way you see when the energy hits the of the edge of the planets, when they hitting, when it shoots, you see harder it hits, the farther it will travel, obviously, and closer it gets. But it's not hitting hard enough, and that's why it travels. It leaves long trail of triangle right behind the planet, and this is the fact what I'm saying, and I can prove everything what I'm saying, and let's go back, again, see, how true it is. And another fact that Mr. Einstein, he mentioned about the planet Mercury, that because of the planet is not traveling in a circle like the planet Earth. Yes, that's true. But again, let's take our sun's energy. The energy, you see, it goes according by the concentration of the energy. Closer to the sun's energy is lot has more concentration than the sun's energy farther away from sun. For example, the sun's energy, the farther it goes, the thinner it gets. We have the good example and the facts right here on Earth. Why do you think, right after 59 miles into the surface, out of the surface of the Earth, and suddenly we lose the gravity force? What exactly mean that? It means that, the gravity gets thinner. It has so many layers, so many layers. How I explain, I can show you here. Okay, now, this is the way it is, actually, the inner core. You see, it has the layers. This is the way, is the inner core. It has the layers, it starts from the center all the way to out. Now the one, it travels farther away, and the fastest is the one all the way from the center. Now each layer, each time the layer it change, it gets shorter and it decreases the speed. I mean, the lowest speed will have the one, right on the top of the surface of the inner core. I mean, it doesn't have, because it doesn't have much pressure to it. Though now I explain, in one of my video clips, when you take the snow, when you're making a snowball, you give, you see, your pressure over the snowball is proportional, but the inner core, it actually pulls from inside out, and that's the way it travels too. The energy inside, it travels fastest and farther away. And the one, from outside, it travels slowest and not far from the inner core. This is what exactly causes the friction between the energy from the deep inside and the energy from top of the inner core of the planets. Again, I said there are no exception to the rule. It doesn't matter, they are old or new.